Hello guys, my name is Bino, and in this video we'll be focusing on question 4 from the April 2nd 2020 N5 mathematics question paper. Question 4.1.1, we have to evaluate the integral of 4 over sec x multiplied by e to the power sine x dx. We can rewrite our integral as, so that 4 is a constant, we can take it out of the integral and rewrite our integral as 1 over this sec x. So we know that sec x is equals to 1 over cos x. So we can write that sec x as 1 over cos x. And that e to the power sine x, we can write it as e to the power negative sine x dx. And this 1 over cos x is equals to cos x multiplied by the e to the power negative sine x dx. From here we have to let that sine x, we let u equal sine x, we differentiate the u with respect to x. The derivative of sine x is equals to cos x. We multiply both sides of the equation by the dx, so that dx will cancel out with that dx, and du will be equals to cos x dx. Let's further rewrite our integral as, so let's start with that e to the power minus sine x, and let's end with the cos x dx. So cos x dx is equals to du. So in the place of this cos x dx, we will substitute du, and in the place of the sine x, we will substitute u. From here we integrate the e to the power negative u with respect to u. So this will be e to the power negative u divided by negative 1 plus c. This is just the same as negative 4 e to the power negative u plus c. And let's substitute back the sine x in the place of u. So we can write this e to the power negative sine x as 1 over e to the power sine x plus c, and this will be our answer for question 4.1.1. Question 4.1.2, we have to evaluate the integral of arc cos of 2x raised to the power 4 all divided by 1 minus 4x squared dx. To evaluate this integral, we have to use our formula sheet. We know that the derivative of the arc cos of x is equals to negative 1 over 1 minus 4x squared. In this case, we have cos 2x, so the derivative of the arc cos of 2x will be equals to negative 1 over the square root of 1 minus 2x squared, which will yield 4x squared. So we let u equal arc cos of 2x, then we differentiate the 2x, the du with respect to x. So the derivative of this arc cos will be equals to negative 1 over 1 minus 2x raised to the power 2, and we also have to differentiate this 2x according to the chain rule. So the derivative of this 2x will be equals to 2. So du over dx is equals to negative 1 multiplied by 2, which is negative 2 over the square root of 1 minus 2x squared, which is 4x squared. So we have, so let's from here multiply both sides by dx, and that dx will cancel out with that dx, and du will be equals to negative 2 over 1 minus 4x squared dx. So let's divide through by this negative 2, so that we can have this dx over the square root of 1 over 1 minus 4x squared, similar to that. So we divide both sides by the negative 2, and du over negative 2 will be equals to 1 over 1 minus 4x squared dx. So in the place of this 1 over the square root of 1 minus 4x squared dx, we'll substitute du over negative 2. So we have the integral of, in the place of this arc cos of 2x, we substitute u, but the arc cos of 2x is raised to the power 4, so we raise that to the power 4. And in the place of this dx over 1 minus 4x squared, we will substitute du over negative 2. So we can take this negative 2 out of the integral, this negative 1 over 2 out of the integral, so that inside the integral we have u to the power 4 du. And from here we integrate u to the power 4 with respect to u. So this will be u to the power 5 over 5 plus c. And this denominator 2 multiplied by that denominator 5 will be 10. U to the power 5 plus c. So in the place of this let's substitute back the arc cos of 2x. And this is raised to the power 5 plus c. So this will be arc cos of 2x raised to the power 5 minus over 10 plus c. And this will be our answer for question 4.1.2. Question 4.1.3, we have to evaluate the integral of x cubed plus 2x squared plus 9x minus 17 all divided by x plus 4 dx. We have to use long division to evaluate this integral. So we divide this x cubed by that x, and this will be equals to x squared, and this x squared multiplied by that x will be equals to x cubed, and this x squared multiplied by that 4 will be equals to positive 4x squared. From here we minus, so x cubed minus x cubed will be 0. 2x squared minus 4x cubed will be equals to negative 2x squared. We bring down that positive 9x. So we divide this negative 2x squared by that positive x, and this will be equals to negative 2x. We multiply this negative 2x by that x, and this will be equals to negative 2x squared, and this negative 2x multiplied by that 4 will be equals to negative 8x. From here we minus again, so negative 2x squared minus 2x squared will be 0. 9 minus 8x will be equals to 17x, and we bring down that negative 17. So 17x divided by that x will be equals to positive 17, and 17 multiplied by that 17 will be equals to 17x, and 17 multiplied by 4 will be equals to 68. From here we minus 17 minus 17 will be equals to 0. Negative 17 minus 68 will be equals to negative 85. And from here, this 85 does not have x, so we have to divide it with that whole denominator, x plus 4. So now we have to integrate x squared minus 2x plus 17 minus 85 over x plus 4 instead of integrating that whole thing. So the integral of x squared is x cubed over 3. The integral of negative 2x is negative 2x squared over 2. The integral of 17 is equals to 17x minus the integral of, so we can write this as negative 85 multiplied by 1 over x plus 4. So when we integrate that, so when we integrate the 1 over x plus 4, this 85 is a constant. This will be ln of x plus 4 plus c. That 2 will cancel out with that 2, and we'll have negative x squared plus 17x minus 85 ln of x plus 4 plus c as our final answer. In 4.1.4, we have to evaluate the integral of cos of 3 pi x multiplied by cos of pi x dx. We use our formula sheet to evaluate this integral where we have cos and cos. So the formula for cos and cos is this one. So it says that cos A multiplied by cos B is equals to 1 over 2 into cos A plus B plus cos of A minus B. So our A will be equals to 3 pi x, and our B will be equals to the pi x. So we have cos of 3 pi x multiplied by cos of pi x. This will be equals to 1 over 2 into cos of 3 pi x by the pi x plus the pi x plus cos of 3 pi x minus cos of minus the pi x pi x plus pi x is equals to 4 pi x plus cos of 3 pi x minus pi x will be 2 pi x. So we'll be integrating this 1 over 2. We can write it out of the integral, or you can just write it in front of the integral if you choose to. Cos of 4 pi x plus cos of 2 pi x dx. So the integral of this cos is sine 4 pi x, and since we are integrating, we have to divide by the derivative of this inner function 4 pi x. So the derivative of 4 pi x is 4 pi, and the integral of cos is sine, but this is 2 pi x, and we have to divide by the integral of this 2 pi x, which is 2 pi plus c. So you can choose to distribute this 1 over 2. So this 1 over 2 multiplied by that 1 over 4 pi will be equals to 8 pi, and also distribute that to that. So the denominator 2 pi multiplied by the denominator 2 will be 4 pi plus c, and this will be our answer for question 4. Question 4.1.5, we have to evaluate the integral of x multiplied by the square root of 1 plus 2x dx. There is no formula for evaluating this integral, so we have to let u equal 1 plus 2x. We differentiate the u with respect to x. So the derivative of 1 is equals to 0. The derivative of 2x is equals to 2. From here, we multiply both sides of the equation by dx. That dx will cancel out with that dx, and du will be equals to 2 dx. We divide both sides of the equation by 2, and dx will be equals to du over 2. So in the place of the 1 plus 2x, we substitute u, and in the place of dx, we substitute du over 2. So we have to get rid of that x so that we can integrate with respect to u alone. So we have that u is equals to 1 plus 2x. Let's make x the subject of the formula. We divide both sides by 2, and that 2 will cancel out with that 2, and x will be equals to u minus 1 over 2. So in the place of this x, we substitute u minus 1 over 2 multiplied by the square root of u du over 2. This denominator 2 multiplied by the denominator 2 will be equals to 4. And this u, we can write it as u to the power 1 over 2 du So from here, we can distribute this u to the power 1 over 2 inside the parentheses. So u multiplied, so u to the power 1 multiplied by u to the power 1 over 2 will be equals to u to the power 3 over 2. Negative 1 multiplied by u to the power 1 over 2 will be equals to u to the power 1 over 2 du. We integrate with respect to u from here. So the integral of u to the power 3 over 2 will be equals to u to the power 5 over 2 multiplied by 2 over 5 minus the integral of u to the power 1 over 2 will be equals to u to the power 3 over 2 multiplied by 2 over 3 plus c. So we distribute this 1 over 4 inside the parentheses. So this 1 over 4 multiplied by the 2 over 5 will be equals to 1 over 10 u to the power 5 over 2 minus 1 over 4 multiplied by that will be equals to 1 over 6 u to the power 3 over 2 plus c. So in the place of u, let's substitute back the 1 plus 2x raised to the power 3 over 2 plus c. We can simplify this further by writing this as the square root of, or you can just leave it here, 1 plus 2x raised to the power 5 minus 1 over 6, the square root of 1 plus 2x raised to the power 5 plus c, and this will be our answer for question 4.1.5.